Hello folks, we are once again back with the next session of this exercise 6.5, which is not getting over at all. So we are there with now the problem number 20. Yeah, it's a problem number 22 that we need to do. Let's read through the problem. A wire of length 28 meters is to be cut into two pieces. One of the pieces is to be made into a square, another is to be made into a circle. What should be the length of the two pieces so that the combined area of the square and the circle is minimum? I've tried to put that question up as a figure over here. That there is this wire. This wire has length 28 meters. They have told you. Now, what we are going to do is this wire, we are going to, I'm moving the unit, moving at the unit, whether it's meter or yeah, it's meter. So, this wire, we are cutting at a certain place, and then we are twisting it and making it a circle, and the other piece, we are twisting it and we are making it a square. That is what is happening. So, it's cut at a certain place, and from that place, this part is taken, converted into a square. This part is taken and wound in the form of a circle. This is what happens. This is the scenario. Now, for this, with this much data, they ask us to find out the combined area of both of these square and the circle, and they ask us to show that this combined area is minimum of the square and the circle together. So let's see now how we can do it. Combined area is what we have to find. And as you see in the figure, this wire which is cut into two parts, the square, we assume that let the side of the square be L and the radius of the circle be R. So with that assumption, we are moving across to do the problem. So let's see how it works. So let's write here let L comma R be the length of the square and the radius of the circle. So what? It is clear that, yeah, it's very clear to us that the perimeter of the square plus the circumference of the circle is going to be the length of the wire. Because that wire is cut and it's made like that. So that's what is happening. And perimeter of the square, because we call that the side as L, so perimeter of the square is going to be 4L. Because we have called as the radius of the R, we know that the circumference of the circle is 2 pi R. And length of the wire we know is 20. Now it's very clear to us that we have to find out the area, combined area, and combined area is going to be pi R squared plus plus L squared, because the side is L, so its area is going to be L squared. Now, when you look at the area has also got two parameters. It has got L also, it has got R also, which is very difficult for us to work. We are not comfortable with two variables. So we may need a substitution there. With that scenario in mind, we can make a substitution and keep it ready so that we can use it for the steps that is going to come up later. So maybe 4L can become 28 minus 2 pi R, where L can be 28 minus 2 pi R over 4, or if you want to simplify this, 7 minus pi R over 2, maybe that can be your value of L. Now, we don't know whether L will be comfortable for us or R may be comfortable. Sometimes it would be that we would have calculated the L and kept, but then L would not be so convenient as far as the working is concerned. Maybe R is comfortable. Then in that case, we can quickly find out what is R and then we can resubstitute. So that also we can do. So this is going to be the substitution that is going to help us. The combined area, anyhow, there's no point wasting time. Let's go for the required thing, the combined area. The combined area A is the area of the circle plus the area of the square. Area of the circle is pi r square, area of the square is L square. So pi r squared for us, we keep it as it is, and L we can substitute from here, that is 7 minus pi r over, not overall, only the pi r is over 2, the whole square. Now why we got this? We got this from 1 because we did not want to work with the two variables r and L. We we wanted to reduce the L into R, which we had already done in Chem. So there we are going to work. Now the A is not in such a convenient form. So we will try to get it more simplified before we go for the differentiation. So this is pi r squared plus when we expand this a minus b whole square, this is 49 minus 7 pi r plus pi squared r squared over 4. So when we do the expansion. So that's a for us. Let's anyhow we know that we require the first derivative and second derivative. So let's go for the first derivative, which is 2 pi r for this. 49 is the number of derivative, and here the derivative is going to be minus 7 pi plus pi squared over 4 will stay as it is, and r squared will give the derivative to what. So then in that case, you have this as your dA over dr. Since we require d squared a over dr squared, let's go for that. So this is going to be 2 pi plus pi squared over 2. So that's our d squared a over dr squared. Now it is for us to find the critical point. So for that, let's get dA over dr to be equal to 0, which is going to be 2 pi r minus 7 pi plus pi squared r over 2 equal to 0. Let's simplify it so that we can get an r. So let's simplify it over 2. So this has to be multiplied by 2 and this has to be multiplied by 2. So you get 4 pi r minus 14 pi plus pi squared r over 2 equal to 0. So the 2 can be dumped on the other side. You can have the 0 multiplied by 2 so that the 2 is gone off. And we also see that there is a pi common. So let's take the pi out also. So here you are left with 4r, you are left with minus 14 pi, and you are left with pi r. When we take the pi common, 2 has already gone to be assumed. So this 0 pi can go next. In the next step, you can divide throughout by pi. So like that, you will be left with 4r minus 14 pi plus pi r equal to 0, which is pi plus 4. Yeah, it's pi plus 4 times r. A equal to 14 pi. R can become 14 pi over pi plus 4. R. So that's R. So from R we'll try to get the L value. But before that, let's confirm whether it is going to be maximum or minimum. So d squared a over dr squared at r equal to 14 pi over pi plus 4 is always going to be a positive quantity. Why? Because these are all positive quantities. So whenever you have the second derivative positive, you know that minima occurs. So minima occurs. That we know. Irrespective of the value, but then we just ensure. Okay, now having got that, let's try to get the value of L over here. L is going to be 7 minus pi over 2 times R. R for us, but is 14 pi over pi plus 4. That's 7. So let's equalize this. 7 over pi plus 7 times pi over plus 4 minus 7 pi over pi plus 4. So that's going to be 7 pi plus 28 minus 7 pi over pi plus 4. That can make the 7 pi go, and you get the L value as 28 over pi plus 4. Now see, all this is not our question. We have to keep a track of the question, and the question says that find out what should be the length of the two pieces. So we have to get the length of the two pieces. And what are the length of the two pieces? The length of the first piece is 4L and the length of the next piece is 2 pi r. So therefore let's find that. Therefore length of the pieces. So first piece, first one, it's 2 pi r. So that's going to be 2 pi times r, which is 14 pi over pi plus 4. Wait, because this pi, we have taken it common. I'm going to get the pi again here. We have taken the pi common over here. It's just 14. So let's let just pi. That's not just pi because the pi is already common and has gone out. Alright, so here it's just, so that's going to be 28 pi over pi plus 4 meters. Then next piece is 4L. So that's going to be 4 times L for us. That's 28 over pi plus 4. So 2, 8, okay. 112 over pi plus 4 meters. So that's our answer. The length of the two pieces. That's got it. Now wire being bent. The catch of the problem is to realize that the length is equal to the perimeter. This is the catch of the problem. If you're able to realize this, the other things are more or less monotonous. You know how to do it. Just use them. So that's how it is. So that should be all for this video. With the next problem, maybe we can meet in the next video. Thank you.